So we already know that in a real world scenario, what happens is that we have some data available. Data could be in the format of text, images, speech. It could be structured in nature, or it could be some 3D signals which is available from an end device, right? So any IoT device might be sending out their signals. We can use all of this data to train a machine learning model, which is basically a foundation model. And once this model has been trained, using this data set, you can then adapt it or use it as a pre-trained model and use it to solve various kind of tasks. So these tasks could be as simple as some question answering mechanism in which you give a prompt and the model will then answer your questions. It could be a sentiment analysis engine which essentially predicts if the input is positive, negative, neutral, and so on. We could use it for information extraction, in which we want to extract some relevant piece of information from the underlying corpus. So you want to extract some a piece of information from the chunk of text which you have fed to the model in the first place. We can use it for image captioning, object recognition, and instruction following as well. So all of these tasks, we can take the foundation model and then adapt that model to any of these listed tasks. Right? So that is basically how we use machine learning models in current day and age. The reason being, the foundation model is not trained on a small data set, or it's not trained just using a commodity hardware. Typically, researchers spend millions and millions of dollars in getting access to a good quality data set. They spend millions of dollars in creating the architecture or the infrastructure for training these machine learning models. And they make sure that that architecture that they have built, it's state of the art, right? So you cannot replicate that architecture on a day-to-day basis. So what we tend to do is, once those models are trained, we use them as a foundation model and then adapt them to our respective tasks that we wish to accomplish. So the objective of today's session here is multifold. We'll first understand how to essentially gain a good theoretical understanding of text-to-text generative models. So in this session, we'll begin with taking an understanding of a theoretical underpinning basically of text-to-text generative models. So how text-to-text generative models basically work. And the foundation of this is a transformer-based architecture which we have covered previously, and I'll walk you through the architecture once again. So we refer to these current state-of-the-art models as LLMs, or large language models, right? So these large language models are what currently being used out there. So ChatGPT, BERT, any of the model you name, all of those are essentially your large language models. To understand their strengths and weaknesses, we'll then see how these LLMs are pre-trained and fine-tuned in practice. So in a real-world scenario, how do you pre-train and fine-tune these large language models? We will see what practical considerations you have to keep in mind while deploying these generative models. This could be for inference, response quality, staleness, toxicity, and so on. So a lot of times, a lot of discussion happens not only around what the model is generating, but also around the quality of what it is generating, right? So whether it is biased, whether it is giving an impractical view or inaccurate answer, or something which is not feasible in a real world scenario, right? So all of those needs to be ensured. And finally, art of reading papers and staying abreast with the field, right? So this is an ever evolving field. Every year there is a new architecture that is released. So you need to understand how to read the papers and how to stay abreast in the current field of large language.